right. Well, it is 12:30. You ready to start, Dale?
Anytime.
Okay. So welcome, everybody. We are excited to continue our new FAFP webinar series this afternoon and glad for the excellent turnout. We also like to thank our members and sponsors for your ongoing support. I just want to start with a few housekeeping items. Please keep your video and audio turned off throughout today's program. We'll ask Dr. Grinstead to answer questions from the audience at the end of his presentation, and we have a team of volunteers that will be monitoring the chat box and facilitating your questions with Dale, so please enter any questions you have directly in the chat box. We will also be recording the program and posting it on fafp.net, which is our newly revamped website, so please check it out. Many of you know that we were supposed to have our annual educational conference in St. Augustine a few weeks ago, where we would have celebrated our 75th anniversary. We're lucky that many of the excellent presenters we had lined up for the conference had agreed to present our webinar series instead. Our speaker today is Dale Grinstead. Dale Grinstead is a PhD Senior Technology Fellow with Diversity, which is also one of our sponsors. He is a food microbiologist with over 20 years of R&D experience. Most of his work has been in the area of food safety, microbial control in built environments, regulations regarding biocides and food safety, leading innovation projects and teams, and consulting with customers, both internal and external, on microbial issues. Today, Dale will be talking to us about Listeria control. And so with that, I will unshare and turn it over to you.
Okay, let's see if I can get this thing to work here. Share screen. Okay, can you see my screen?
Yes, we can.
Okay, let's get started then. Okay, well, first of all, thank you, everybody. I really appreciate the invitation and the opportunity to come chat with you today. I also need to kind of apologize a bit in advance, just so you'll know, I do have a very vocal cat, and I'm doing this from home. So I'm pretty sure she considers any time that I'm not actively putting food into her bowl as a waste of effort on my part. And she tends to let me know that. So I apologize in advance if we get a lot of meowing. So here's our agenda today. We'll talk a bit about what Listeria is. I'm not going to spend a lot of time on that because I suspect most of this audience is pretty aware. And we'll talk a little bit again about why you should care about it. Once again, I think that would be kind of preaching to the choir here. We'll spend most of our time talking about how you control this particular organism in a food facility, and then we'll end up with a little bit of who can help you. And we may take a side excursion or two along this way as well on some relevant side topics. Let's go to right. There we go. So what is Listeria? Well, this is the sort of slide that I think pretty much every microbiologist is required to give, or they take away our union cards. Listeria is a gram-positive, non-spore-forming rod. There's a couple different species of Listeria. Obviously, the one that we get all worked up about here is Listeria monocytogenes. And that's for the most part what I'm going to talk about today. These last three actually can occasionally cause illnesses, but it's pretty rare. So for the most part, we really don't care too terribly much about them because the illnesses are pretty uncommon. Well, what does Listeria do? Well, it does pretty much what other bacteria do. One of the relevant things is that it does form biofilms, or at least it can colonize biofilms that other organisms have formed. Now, that's pretty important for Listeria control, and I'll talk more about that later. But in general, biofilms are bacterial communities, right? These bacterial communities are built by the microbes themselves, and they can contain hundreds of different kinds of bacteria as well as other kinds of organisms. A biofilm can contain yeasts, mold, algae, protozoa, viruses. The thing about biofilms is that, one, they're very difficult to remove from surfaces. 2, they are very common, and 3, they form very, very quickly. And so we'll talk more about biofilms and how they're relevant to Listeria control in a bit. Listeria can also grow at pretty high salt levels. Now that means that it can grow in food. And by the way, if you think about a food facility and the soil that we have in those facilities, that's largely food as well. And Listeria can grow then very nicely in the soil in a food facility. It's a bit heat tolerant, but one of the reasons that we get really concerned about this organism is this last one I listed here in red. Listeria will grow at refrigeration temperatures. Now, mind you, it doesn't like to grow at refrigeration temperatures. It doesn't grow well at those temperatures, but it can grow. And this really is one of the reasons that we need to be concerned about Listeria, because what that means is that one of the most important tools that we have to control the growth of pathogens in our food simply does not work as well to control Listeria as it does other organisms. And that you can have food that is properly refrigerated and still get Listeria growth in it. Again, it doesn't like to grow at refrigeration temperatures, but it can do it. And that's a big problem. Other things Listeria does, well, it does all the stuff other bacteria do, right? It eats, it excretes, it reproduces. But obviously the one that we get very concerned about is that it makes people sick. Now, the good news here is that it doesn't make people sick very often. This is a pretty uncommon illness. The illness rate's about 5 cases per 1 million people in the population per year. That works out to be roughly 1,600 cases per year in the US. Now, it could be better, mind you. The national health objective for 2010 was about half that much. So we haven't quite hit that yet. But it's better than it was, 15 years ago, 20 years ago. So we're trending in the right direction. So it does make people sick, but fortunately not very many. And for healthy adults, the infective dose is actually pretty high. For a healthy adult, it can take up to 1 million organisms to make somebody ill. Now, however, like my grandmother used to say, you have to take the bad with the good, because even though the listeriosis illness is uncommon, it is extraordinarily serious. When this does make someone sick, it's a doozy. This illness can generally starts as flu-like symptoms. In many cases, that's where it stops. But it can rapidly advance to far more serious problems. Listeria has been linked to septicemia, meningitis, encephalitis. It can cause spontaneous abortions and miscarriages. If you get listeriosis, it's about 90% likely to land you in a hospital, and frankly, about 15% likely to land you in a grave. This is a very serious illness indeed. And just for some context for this, that mortality rate is worse than botulism and malaria. In fact, you get about the same odds with getting bubonic plague or playing a quick round of Russian roulette. So listeriosis is not a trivial illness. And this is the second reason that we get so concerned about this organism. Remember, the first one was that it grows at refrigeration temperatures. The second one is that although it causes an uncommon illness, it causes a very, very serious illness. And it's even more serious for the immunocompromised population. That population is quite susceptible, and effective doses are much lower for that group, as low as 100 organisms compared to 10 to the 6th for other healthy adults. Also, I'd point out that pregnant women are particularly vulnerable to listeriosis too. Well, where can you find Listeria? Well, a $10 word that microbiologists like to use is ubiquitous. I think it's kind of an unwritten rule in microbiology that never use one syllable when you can get away with using 3. But Listeria is found really everywhere. Common natural reservoirs, soil, sewage, silage, about 20 different species of birds and mammals, including, by the way, humans. Some studies have suggested that as many as 10% of humans may be asymptomatic carriers of Listeria. And not only is it out there in the natural environment, it's in our food facilities. To be honest, I don't know how we would ever keep this out of our food facilities. I don't know, maybe flamethrowers at the doors or something. But numerous studies of all types of food facilities, retail, grocery, food service, food processors can find this organism. Typical locations: drains, floors in general, handles, switches, floor mats, particularly if they're wet, any standing water, floor wall junctures, especially if they've been kind of damaged, can cause a problem. HVAC systems. Listeria has been isolated from HVAC systems. I know I've pulled it off of cracked and worn hoses. Cleaning tools, ironically enough, in particular squeegees, are notorious for carrying Listeria. So this is really kind of the third reason. This organism is very common in our food facilities, right? And so we get very concerned about Listeria because of that. It's one of the most commonly found pathogens in the general food environments where we operate. By the way, not only does it contaminate food facilities, apparently it's quite comfortable there. A number of studies have found that actually Listeria strains can persist for weeks to even years in these sorts of food facilities. Now that means a couple things. One, like I said, the Listeria is not just sitting there, it's actually actively surviving and growing. It also means, by the way, that the cleaning and sanitation practices that you were employing weren't effective to remove it. Okay, so this organism was essentially surviving the key controls that we try to use in order to prevent it from becoming a problem. And by the way, it can be found in food. Now, again, fortunately, it's not terribly common in food. An old study from the 90s looked at about 30,000 different samples of deli type foods, lunch meat, deli salads, that kind of thing, and found that a bit less than 2% of them were positive for Listeria. So this organism can be found in food, and again, because of the ability to grow at relatively high salt levels and at refrigeration temperatures, means that even if this food is properly refrigerated, it may still be able to grow to levels that can cause illness. So then, there are three main reasons why you need to care about Listeria. I've already called them out. First of all, very common organism, right? Contaminates food environments very easily, and in all honesty, I don't know of an actual way to guarantee that Listeria will never contaminate a food environment. And I think that's particularly true for an open environment like a retail grocery or a restaurant where you have people coming in continually. It's hard enough to control it in a food processor where you have very limited access to the facility. But for a retail grocery or restaurant, I just don't know how we could ever even hope to keep this bug out permanently. This organism does grow at refrigeration temperature, so if it does get into food, one of the main ways we have to control pathogens does not work as well against Listeria as it does against other organisms. And then finally, of course, Listeria causes an extraordinarily serious illness that has tremendous human costs and financial costs as well, and frankly can put a business operator at great liability risk. And, you know, there's actually kind of a fourth reason that we need to be concerned about this. And that's that even if the first three don't get your attention, trust me, the federal and state agencies, the people who regulate us as food operators, they're all very aware of those first 3 points. And many of them have quite aggressive sampling programs. I think Florida does quite a bit of sampling of facilities in your state. And if this organism is found in one of your facilities, it will end up being kind of a bad day for you. So that kind of is sort of the fourth reason that we need to care, which is that people who are very influential over us care about it too. Okay, so clearly then we have a microbiology problem, right? We have Listeria where we don't want it in our facilities. How do we handle it? Well, fortunately, as an employee of a chemical company, I have a solution. It's easy. We just use a sanitizer, and that will control this organism. And if that doesn't work, I have a backup solution. We can use more sanitizer. And if that doesn't work, I have yet one more step we can use. We can use great, huge gobs of sanitizer. And if that doesn't work, well, I think you kind of get the point. Or maybe not. Here's some data that we collected some time ago. We were doing this work in a food facility. We were looking at this is on floor drains. and we were looking at Listeria in floor drains. In this case, we were quantifying the Listeria. Now, the thing about Listeria, it's present in a lot of floor drains. Roughly 30% of drains in some operations like retail groceries are typically positive for Listeria. It's never there as the predominant organism on those surfaces. So they're usually relatively low levels, but you can frequently find it. In this case, we had found this organism to be present on the drains in this facility at roughly the area of 1.5 log per square centimeter. That's, call it 70, 80 organisms maybe per square centimeter. So the first thing we tried, sort of using that gobs of sanitizer thought, was a quat. And not just 200 part per million. Oh, no. We used 2,000 part per million of quat to treat those drains. So 10 times what you would normally use a quat at in a food facility. And we did effectively nothing. The small reduction isn't statistically significant. So we basically didn't even phase this organism with quat. Well, we then thought maybe we're using the wrong sanitizer. So we tried chlorine dioxide. For those of you who may not be familiar with it, chlorine dioxide is kind of the bazooka of the sanitizer world. And we tried a huge quantity of that. And we got better results, but still didn't get rid of it, not even quite a log reduction. So these sanitizers just were not working. So what happened? Why didn't sloshing more chemical at this problem fix it? I mentioned this already. In the environments where you find Listeria, it is growing in a biofilm. In general, if you find Listeria in a food environment, you should just assume that it's part of a biofilm. Now, Listeria apparently doesn't form biofilms terribly readily on its own. It can, but it really loves to move in with biofilms that other organisms have formed and finds a very ready home in those facilities. Now, a biofilm is, like I already said, just a community containing many different types of microorganisms. And it is protected by a substance called the EPS, extracellular polysaccharide, that is secreted by the bacteria in the film. Think of it as shelters that the bacteria build themselves. Effectively, there's no nice way to put it, it's bacterial snot. The organisms can live in that, and that material protects them from harsh conditions, protects them from dehydration, and it will also protect them from biocides, like disinfectants and sanitizers. So how do we control that biofilm then, right? We saw just throwing gobs of sanitizer doesn't work very well. Let's think for a minute about what a biofilm is. What's a biofilm made of chemically? Well, that exopolysaccharide is, as you would expect from a polysaccharide, largely carbohydrate, but there's a good bit of protein and DNA in there too. It's left over from when the microorganisms that are living there die and they kind of break down. They leave some of their protein and DNA behind. And of course, there's microorganisms living in the biofilm. Chemically, they're made of carbohydrate, protein, lipids, and minerals, a few other things. Well, what about something else that we find a lot in a food facility? Well, the soil in a food facility is basically food, right? And what's that made of? Well, food is carbohydrate, protein, lipid, DNA. These are sounding pretty similar to me. In fact, I would argue that the way to control the biofilm is not to think of it as a microbiology problem, but to think of it as a cleaning problem. To think of biofilm as a soil rather than a microorganism. And that then gives us sort of the keys to controlling it. Oh, by the way, I gotta say, I love this picture here on the left, but I should point out, that's not my hand. That was a biofilm we found in a drain pipe from a cooler. I'm off camera going, God, please wash your hands. But it's a good picture though, I love that picture. Anyway, so what removes the biofilm from a surface? Well, if it works like a soil, if it responds like a soil and you should treat it like a soil, then all the variables that you can use, all the buttons you can push and levers you can pull to improve cleaning performance should also improve removal of a biofilm from a surface. Now, Interestingly, while you're actually cleaning, there's not that much we can control to impact cleaning. The acronym I use to remember the variables is TACT. Basically, time, action or mechanical action, chemical, and temperature. So essentially, you can clean longer and get a surface cleaner. Mechanical action, you can scrub harder to a point. You scrub too hard and you'll damage the surfaces and then you'll never get them clean. Chemical, right? You can use a chemical to help you clean, or maybe a different concentration of chemical. And then finally, temperature. All cleaning, all soil removal is basically a chemical reaction. And as a rule, chemical reactions happen faster at higher temperatures, although like mechanical action, there's an upper limit to this too. If you get temperatures too high, well, one, it's dangerous for people doing the cleaning, but also you can actually cook the soil onto surfaces. So with most of these variables, you can also overdo it. There's sort of a Goldilocks zone that's just right, not too little and not too much to get all this to work well. Now, I'm not going to discuss all these in detail. I do want to touch base just on the chemical, just to give you a little bit more data to show how that can impact biofilm removal. This is some data that we collected in our labs looking at Pseudomonas aeruginosa biofilms. Now, the world of cleaners can kind of be broken down into two big categories, light duty and heavy duty. Light duty cleaners are sort of things that you might use as hand dishwashing detergents, the stuff you use at home to wash dishes by hand, or the stuff you may use in your restaurant or store to wash dishes by hand. Hand care products can be considered light duty cleaners. Not really intended to get rid of high levels of soil. A key characteristics of these is to have really good looking safety data sheets and to be very safe to be in long contact with skin. Heavy duty cleaners, on the other hand, are used as things like degreasers, or they're used in food processing plants for open plant cleaning. A lot of times these are highly alkaline. A lot of times they're chlorinated. Sometimes even they're highly acidic if they're meant to remove scale, but they're all meant to remove very high soil loads. And indeed, when you look at removal of a biofilm from a surface, you can see these light duty cleaners rarely got over even a half a log reduction. Whereas with a heavy duty cleaner, you were anywhere from 2 to over 4 log reduction. So a much better removal of biofilms from surfaces with these heavy duty cleaners. Now, I don't want to give the impression that sanitizers are useless. They're not. A sanitizer alone cannot control the biofilm that Listeria is growing in, okay? But you have to clean first and then sanitize. The control process really has to be, for Listeria control, regular cleaning followed by sanitizing. That combination will control the biofilms and the Listeria that is growing in those biofilms in a food facility. Here's just a little bit more data that shows that. Again, data out of our own lab. We grew the biofilm. In this case, it was a bacillus biofilm. The max possible line here on the left, that's essentially, think of that as the control. We had a biofilm that consisted of roughly 4.5 logs, a bit less per coupon that these were growing on. If we treated those coupons with just a sanitizer, in this case it was, as I recall, it was 100 part per million peroxyacetic acid, we got some reduction, about a 1 log reduction, which as sanitizers go isn't bad for a biofilm, but still only a 1 log reduction. If we went with an alkaline cleaner, we got somewhat better. We got a 2 log reduction. But if we first used the alkaline cleaner and then applied the sanitizer, we got almost complete reduction. Almost all the organisms are gone, better than a 4 log reduction. So considerably more than you would expect even if it was just an additive effect. So this is basically a synergistic effect of the cleaning and then the sanitizing to help control this organism. Now, one of the things, and I have to say, when you know, I was chatting with Rick and Jason about this talk, I was kind of happy to be asked to talk about Listeria. You know, a year ago, I would have pushed to try and talk about something else. because I was frankly getting bored with Listeria. These days, I have to say, I'm glad to have gotten as far as I have in this and not mentioned COVID. Well, I'm afraid that's going to change just a little bit now, because I want to do a slight excursion. Or to quote Monty Python, and now for something completely different. I want to interrupt this presentation because thanks to COVID, we've been doing something quite different in food facilities that we normally don't do a lot of, right? Traditionally in food facilities, we rely on wash, rinse, and sanitize processes, and we do not do a lot of disinfection in those food facilities. But thanks to COVID, we are now disinfecting far more in restaurants, in kitchens, in food processors than we used to. And to me, that raises some interesting questions, some things that make you go, if anybody else is old enough to remember that reference. And those questions to me are, well, what is a disinfectant? And for that matter, what's the actual definition of a sanitizer? How are these things different? How should a disinfectant be used and when should it be used? So let's try and address those a little bit, because I think these days it's important for those of us who are in kind of the food industry to understand this some. Now, I do have to say that in order to discuss this, we are going to have to discuss regulations. Now, I will be perfectly honest and tell you that this is the expression that I usually get when I'm told that I have to discuss regulations, or that I have to think about regulations, or to be honest, that I have to think about talking about regulations. But we'll get through this. We're going to do this at a very sort of superficial level. The EPA is the group that regulates sanitizers and disinfectants. So let's start with their definitions. What is a sanitizer? According to the EPA, a sanitizer is a substance or a mixture of substances that reduces bacterial population, that's bacterial population, that's important, in the inanimate environment to levels that are considered safe. Again, inanimate environment, right? So that's on hard surfaces, on soft surfaces, not on people. This gets confusing because there are also products out there called hand sanitizers. It is unfortunate that they have the same name. Hand sanitizers are completely different products for very different uses. Hand sanitizers are regulated by the Food and Drug Administration. They're regulated actually as drugs. They are not interchangeable. The best way to think of them is hand sanitizer and surface sanitizers are kind of homonyms, you know, not interchangeable. You know, it's like a bat that you hit a ball with and a bat that goes flying past you at night. Both perhaps useful and interesting, but hardly interchangeable. A hand sanitizer cannot be used in place of a surface sanitizer, and a surface sanitizer cannot be used in place of a hand sanitizer. Okay. Disinfectants, according to the EPA, on the other hand, are a substance or mixture of substances that destroys or reversibly inactivates bacteria, fungi, and viruses, but not necessarily bacterial spores, in the inanimate environment. Again, inanimate surfaces. The fact that these do not eliminate bacterial spores mean that these do not actually sterilize a surface. There are chemical sterilants, but trust me, you would not want to use them. Let's unpack these definitions a bit and compare and contrast just a bit than what we're dealing with when we talk about sanitizers and disinfectants. Sanitizers are only effective against bacteria. Okay, disinfectants can be effective against bacteria and maybe some viruses and fungi. Disinfectants get complicated because essentially, if I'm making a new disinfectant and I want to claim that it kills whatever microorganism, I pretty much can make that claim as long as I generate data using the methods the EPA tells me to use that demonstrates that it's effective. I submit that data to the EPA and they say, yep, this is correct. You can make the claim against whatever organism you tested against. So I can test a disinfectant against any number of different viruses and fungi. And if it works against those organisms, I can make the claims against them. Okay, there are certain minimum organisms that I have to test against, which are just bacteria, but I can make all sorts of claims if I can generate the data that shows it's effective. Sanitizers, Doesn't matter what kind of data I may generate showing it kills viruses, cannot make an antiviral claim for a sanitizer. By definition, sanitizers only kill bacteria. Sanitizers reduce target organisms to safe levels. They don't necessarily eliminate all of them. Disinfectants, however, inactivate nearly all the susceptible microorganisms from a surface. They generally have a much higher level of efficacy than a sanitizer does. As far as where they're used, sanitizer is most commonly used in food settings, right? That's what we're used to using all the time. Sanitizers are frequently used on food contact and non-food contact surfaces. Those are technically registered somewhat differently with the EPA, although frankly, almost any sanitizer that you would use in a food setting is both a food contact and non-food contact sanitizer. It's registered for both applications generally. Disinfectants largely used in healthcare settings, so hospitals, nursing homes, those kinds of locations. Sanitizers are not rinsed from food contact surfaces. Pretty much all disinfectants must be rinsed from a food contact surface. Because they're a higher level of efficacy, even if they may be the same chemical, maybe it's a quat-based disinfectant, just like we have quat-based sanitizers, we're usually working at much higher levels in a disinfectant though. And so generally disinfectants must be rinsed from food contact surfaces. Sanitizers, however, cannot be rinsed from food contact surfaces. Most sanitizers have a 60-second contact time. There are actually a few with shorter contact times, but those are almost all used in dishwashing machines. But for most of the sanitizers we would use, like for hand washing dishes or ware, sanitizing a piece of equipment like a slicer or a cutting board, those all have 60-second contact times. Disinfectants, exposure contact times are all over the map. Again, in the same way that I can do testing against any organism I want for a disinfectant and demonstrate it's effective, I can use virtually any contact time, up to 10 minutes, to demonstrate that it's effective. And what that means then is that you can have disinfectants that have a contact time as low as 1 minute. I've even seen a few at 30 seconds, or as long as 10 minutes to be effective, and anything in between. In fact, it gets even more complicated because in some cases, and I've seen this in some disinfectants, well, it's 1 minute against this organism and 2 minutes against that organism and 5 minutes against this other organism, which is difficult because then you got to know what organism you have on your surface before you try and disinfect it, or you just got to go automatically the longest possible time. I've even seen different contact times in different organisms depending on the dilution for the disinfectant, so depending on the concentration. Disinfectant labels and use instructions can get really complicated. So just be aware they are considerably different than sanitizers. Okay, so which do you need to use? So you're running a food operation, a restaurant, a kitchen, a grocery store, a food processor. Which do you use? Well, let's be super vague about this and just say that depends. Actually, the vast majority of microbial control should continue to be cleaning and then sanitizing, just like we were talking about for Listeria, because that's a process that helps you control bacteria, right? And just because, by the way, we're dealing with COVID doesn't mean that Listeria and all our other usual suspects have gone away, right? A lot of us, I'm sure, have been dealing with a tomato recall we're kind of in the midst of. These other bugs are still out there and still causing us headaches. So the vast majority of what you need to do is still clean and sanitize. But there are some times when you do need to use a disinfectant. And again, it's more common these days than it was just 6 months ago. Obviously, anytime you're trying to control a virus, right, you need to think about, you need to use a disinfectant because again, by definition, sanitizers are not effective against viruses, only disinfectants. So if you're trying to control COVID or norovirus or any other virus, you need to use that disinfectant. But that does not mean that you need to use a disinfectant all the time. That's wasteful and frankly a misuse of these disinfectants. And to be perfectly honest, I'm sure many of you are aware, disinfectants are kind of hard to get these days. You know, I got to tell you, pretty much every chemical company I know of is manufacturing disinfectants just as quickly as we possibly can. And the demand is still higher than we can actually manufacture. So we need to be cautious and not overuse them or misuse them or waste them. So you need to consider disinfecting then when you need a higher level of microbial control. The one place where a lot of us already disinfect and should continue to disinfect is in bathrooms, okay, around toilets, in restroom areas where you really want that higher level of microbial control. And again, maybe more concerned about viruses. Maybe you're a restaurant operation that's been shut down for a while during COVID and you're looking to reopen. You might want to consider disinfecting then before you reopen. Another reason to disinfect, and a reason I think a lot of us have currently been doing it or previously been doing it, is if you have reason to expect a viral contamination. Maybe during a blood or body fluid cleanup, or what we sometimes euphemistically refer to as code browns. You're going to want to consider using a disinfectant because, again, you may need to be controlling a virus in those settings. And once again, disinfectants for viral control. If you've had an employee in your operation that has tested positive for COVID, right, and has been there for a while, you may want to do a deep clean. And if you do that, you should probably consider using a disinfectant rather than just a sanitizer. The CDC also recommends regular disinfection now of frequently touched surfaces. Light switches, door handles, buttons on drink dispensers, that kind of thing, right? Now, they don't tell you what frequent definition, what frequent is, what regular disinfection is, or what constitutes a frequently touched surface. So you kind of got to figure that one out on yourself. I guess my recommendation would be regular disinfection is at least once a day. You may, in some cases, want to do more frequent disinfection of those frequently touched surfaces. Now, I've also seen over the past few months a lot of questions about people wanting to disinfect areas that really don't need to be regularly disinfected or even disinfected at all. I have had questions about floors, walls, ceilings. And as a rule, you don't need to disinfect those, again, unless there's a compelling reason. Exterior areas. I had people asking me how to disinfect a parking lot. I even had one person ask me how to disinfect a pasture. My answer in both cases was generally you don't. You generally don't need to disinfect food contact surfaces, except for those special cases where I mentioned where you may be particularly concerned about a virus. Okay, so again, use the disinfectants only when you need to, but the majority, 90% plus of your microbial control should continue to be to clean then sanitize. If you do use a disinfectant, how do you have to use it? Well, this gets even more complicated because now we have two agencies to please. Because we have the EPA, who regulates disinfectants and sanitizers and tells us what we can do with those chemicals. And of course, we have the Food and Drug Administration, who writes the food code, which guides most states in what we have to do in our food facilities, right? And now we have to then deal with two regulators. And all I can say to that is this. But we'll get through this one quickly too. So the EPA says disinfectants have to be used at the correct concentration, right? That's no different from sanitizers. You also have to keep surfaces wet with the disinfectant for the full contact time of that disinfectant. And that applies no matter how, and that's true no matter how it is applied. And by the way, electrostatic sprayers, I'm looking at you with this. One of the things I've seen a lot is electrostatic spray getting touted. Keep in mind, no matter how you apply this disinfectant, you still have to keep those surfaces wet for the full contact time of that disinfectant. And if that's 1 minute, 5 minutes, 10 minutes, you have to hold that electrostatic sprayer, if that's how you're applying it, at that surface long enough to get it wet for that contact time. One of the things I see regularly with electrostatic sprayers is people waving it around kind of like a magic wand, hoping that it will get rid of all the bacteria, bibbity bobbity disinfect. It doesn't work that way. This is still a chemical reaction. You have to get the chemicals on those surfaces for the contact time of those chemicals. And then finally, again, the vast majority of disinfectants need to be rinsed if applied to a food contact surface, right? That's what the EPA says. FDA in the food code says you cannot rinse after the sanitizer treatment. So basically the fear is, and this is in section 4904.14 of the food code, Annex 3 goes into a bit more detail on it. Basically, once you've cleaned and sanitized those utensils, you can't run them under water or dip them in a vessel, any of that kind of stuff. To be honest, I'm not sure that this is actually something that I particularly agree with, but it's in the code. I don't know, maybe we'll do an issue for CFP next time we have a CFP. But for now, you really cannot rinse after that antimicrobial treatment. Again, a few exceptions in mechanical warewashing machines. So that means that if you're going to disinfect a food contact surface, in order to comply with EPA and FDA, this has to be the process. You wash, you rinse, you disinfect, you rinse that disinfectant off, and then you sanitize. Okay, it's a complicated process. It's an extra couple steps, more steps than we're used to. But to disinfect those food contact surfaces, that's a proper way to do it to keep all the regulators happy. Okay, so in summary of this then, sanitizers are generally a lower level of microbial control than disinfectants. And if what you want to control are viruses and fungi, only disinfectants will work for that. You cannot use a sanitizer to control viruses. In general, sanitizers need to remain the antimicrobial of choice for food environments, and only use those disinfectants if and when you actually need to. You need to keep a treated surface wet with a disinfectant for the full contact time of that disinfectant in order for it to be effective, no matter how you apply it. If you do use a disinfectant on a food contact surface, rinse it after the contact time and then sanitize that surface. And then finally, disinfectants are considerably more complex than sanitizers. The labels are more complex. Talk to your suppliers, talk to your vendors to make sure you're using them properly. And then the final thing I would say, and this is something I have seen sort of crawl out from under the rocks the past few months, are the snake oil salesmen. There is a lot of stuff out there that is very questionable claims. Frankly, if it sounds too good to be true, it probably is. At the end here, I'm going to talk a little bit about where you can reach out for more information. Feel free, to contact any number of people, myself, whoever, if there's something that you hear about that seems kind of dubious but looks really attractive, let's talk about it, because I have seen an awful lot of this stuff out there. An awful lot of people are making some very dubious claims. Okay, so with that aside, we'll now return you to your regularly scheduled presentation, already in progress. Listeria, that's what we were talking about, wasn't it? Listeria. So let's get back to that. How do we control it? Proper cleaning and sanitation. And like I said, this is going to be growing in a biofilm. And so the most critical part of the process for Listeria control is the cleaning. You have to clean before you sanitize. You have to make sure all your chemicals are at the right concentration. Extra chemical does not actually help. I've already talked about how extra sanitizer doesn't help you. Extra cleaning chemical doesn't help you either. By the way, too much cleaning chemical can be hard to rinse and end up causing problems in its own right. And then also make sure the chemicals actually contact the surface being cleaned. And if you're trying to clean and sanitize a surface over here and you're applying all your chemical over there, well, then that's not going to work very well for you. Well, where can all this go wrong? Because it does go wrong. When you're trying to control Listeria, there are some common points where this can fall apart. Most often it's a process issue, right? I realize I'm a bit biased being an employee of a chemical company, but for the most part, these chemicals, the cleaners clean, the sanitizers will kill if they're used properly. But it fails because the process wasn't done correctly. It can fail because it's not done often enough. Hey, production ran late yesterday, so we'll just skip cleaning tonight and go straight into tomorrow's production. That kind of stuff. It can fail because maybe the equipment being cleaned is not cleanable. Maybe the area being cleaned is where you thought the Listeria was, but actually it was somewhere else. And these organisms do move around our facilities. So how do you control the actual process? Because at the end of the day, that really is the most important part of this, isn't the chemicals that you use. It's how you use those chemicals. I have to tell you, I have seen Fantastic chemicals fail miserably because they're not used or they're not used properly. Similarly, I've seen really horrible chemicals made to work because the processes used to clean were brilliant. So you can make almost anything work if you have a good operating procedure, standard operating procedure. So actually, standard sanitation operating procedures, or SSOPs, are what you need. And the SSOPs need to cover all surfaces as well as all processes. Do you clean everything the same way every day? Or do you clean sort of a light cleaning 6 days a week and a deep cleaning 1 day a week? Whatever it may be, you need to have a process for all those different cleaning methods, a standard process. Maybe you have deep cleaning processes, remediation processes, standard processes, all your different surfaces, you know, your slicers, your drains, your floors, your conveyors, your tracks, whatever it may be. Have a regular schedule for cleaning everything. You know, does everything get cleaned every day? And again, is it cleaned in a different way some days? Have a schedule for that. And then have logs and have people accountable. I have generally found that making people accountable for this process is quite helpful in complying with the master sanitation schedule. It's usually pretty clear if something's supposed to be cleaned every day when something hasn't been. And so you have to then ask if people are signing off on these cleaning logs if they've actually done it properly. In general, I find that people like to be accountable. And then finally, of course, put eyes on the process. If you're not regularly in the operations when the sanitation is going on, go in there occasionally and at least observe. Now, I realize this may mean, you know, a night of lost sleep out in there in a third shift or maybe a second shift. But you will learn things by doing that you will never learn sitting in an office somewhere, because a lot of times what you think is the process is not actually what's happening. And the best thing, of course, is to actually do the process yourself, not just put eyes on the process, but to put hands on it too. That can help you understand real quickly that maybe you have a process that takes an hour and a half to perform, but you're only giving people 30 minutes to do it. And then what do you think is going to happen? So you really have to kind of get quite literally, in many cases, your feet wet to best understand these processes and how they're working. What else can we do to help control Listeria? Well, one thing we can do is dry the environment. You know, we talk a lot about a hygienic design of equipment, but there's hygienic design for facilities as well. One of the big hygienic design failures for facilities is standing water. That's usually a sign that there's something gone wrong in the design of a facility. You know, I'm fairly certain that there is some unwritten rule that all architects who build grocery stores have that says that any floor drains must be at the high point of the floor. Because I think that the next floor I see that's sloped to a drain will be the first floor I've seen sloped to a drain. So make sure the process is designed properly to get rid of standing water, get rid of condensation, make sure condensation goes to drains, not just to the floor. Look under sinks to see if you have splash or spilling there from sideboards, floor mats, that kind of thing. Dry the environment to the extent that you can and address the design of your facility so that you can dry the environment. Hygienic design, as I said, we talk about that a lot. That's pretty easy. You know, which surface is easy, which oven is easier to clean. It's the basics of hygienic design. Means that your equipment can be cleaned and sanitized, doesn't have harborage points. And something that gets forgotten a lot, and that's an important element of hygienic design, is that equipment oftentimes has to be disassembled to be properly cleaned and sanitized. And an important element then is that it's easy to disassemble and, by the way, to reassemble. If something is insanely difficult to disassemble, and anybody who's actually tried to do a really good clean of a slicer knows what I mean about something being insanely difficult to disassemble, knows how important this is to hygienic design. So do factor that in when you're looking at equipment, not just the design of the equipment itself, but how easy is it to actually clean? Can it be disassembled? Can it be reassembled, and so on? How you install the equipment matters. You can actually buy a piece of hygienically designed equipment and install it in a poor way and sort of ruin that hygienic design. Now, in these cases, there's lots of bad things going on. But in the case, for example, this pump on the left, you really can't see it very well in this picture, but it was actually raised, part of it was raised about a 1/4 inch off the floor. And what that did was it let water and soil get under it, but then you couldn't clean under it. So that stuff would just ooze back out during the day. And for one thing, it corroded the pump, but it also let a lot of pathogens basically ooze back out into the production environment. In the picture on the right, it was a drain coming from a condensation coming from a cooler that was literally just dripping to the floor. And they had built kind of a berm around it, but it was still there, would occasionally overflow, but was pretty much impossible to clean under there because of that berm. Maintenance, right? Don't forget that equipment needs regular maintenance. Broken equipment, damaged equipment is usually impossible to clean and impossible to get rid of the biofilms and the organisms, including Listeria, that will be growing on the damaged equipment. Cracked belts, poor welds, missing grout and floors, those kinds of things. Hand care, right? Remember I said that about 10% of people carry Listeria? Still got to wash your hands. This gets forgotten sometimes with everything else that we talk about, but hand hygiene is critical for Listeria control. Temperature control. Again, we talked about this. Even though Listeria can grow at refrigeration temperatures, it doesn't like it. Its growth optimum is actually closer to 35 degrees C, not 4 degrees C, but it can grow at those temperatures. So you don't get a pass on refrigeration for Listeria control. So you still have to pay attention to it. Watch for cross-contamination in your facilities, particularly between raw and ready-to-eat areas. Separate raw and ready-to-eat products in display cases, and be very careful of the movement, not just of people in your facility, but equipment too. And that means things you might not necessarily expect. Cleaning equipment, right? Notorious for being able to spread organisms around an environment. You can get around some of it by color coding, but even that's certainly not 100%. Oddly enough, you have to clean the cleaning equipment and sanitize those. And don't forget big cleaning equipment, right? Not just brushes and squeegees, but maybe auto scrubbers. Maintenance equipment is a way this bug can move. You know, a lot of us may have a head of maintenance that has, you know, one tool. Maybe it's a Makita power drill that they just love. And that thing goes with them wherever they go. Well, I wonder when the last time was that this thing was sanitized, cleaned, or disinfected. What else? Obviously training. Process failures are generally people failures, and you generally fix people by training them. So that's important for Listeria control. Now, I will tell you, if you do all these things perfectly, if you do all these Listeria control steps perfectly, and you make no mistakes, the result of that will be Listeria contamination of your facilities. You know, I said at the start of this, gotta say, I warned you, that I do not know of a way to prevent Listeria from ever getting into a food facility. It is such a common organism that it is inevitably going to find its way in. So one of the most important things to do is have a plan. If you do all these things, Listeria contamination will occur less often, but it will eventually occur. And the time to figure out what to do when that occurs is not when you're getting a phone call from the state health department saying, hey, we just picked up some Listeria hits when we came in to sample your facility. What you going to do about those? And by the way, I don't know how the bacteria know this, but they do. They always show up, so you get that call at 4 p.m. on the Friday before either Memorial Day or Labor Day weekend, or occasionally the Wednesday before Thanksgiving. I don't know how the organisms know that, but somehow they do. So have a plan. What are you going to do when you have this problem? Have a recall plan, remediation plan, internal and external communication plan. Okay, and practice that plan, by the way. So, almost to the end here, folks. Tie it all together. Listeria is a foodborne illness that causes a very serious illness, fortunately infrequent though. It commonly contaminates facilities and then can be a risk of contaminating the food that you produce and sell. A critical part of controlling this organism is cleaning, and simply increasing sanitizer use or shock treatments will not be effective for control of this pathogen. It's because it's growing in the form of a biofilm, and you control biofilms by first cleaning, then sanitizing. We're doing a lot more disinfecting these days, but only disinfect when you need to. And remember, if you are specifically worried about a virus, then is when you have to disinfect. Other important parts of Listeria control include hygienic design of equipment and facilities, equipment maintenance and training programs, and have a response plan for failures because inevitably failures happen. And then one final thing you can do is get a bit of help. And there's lots of people out there that can help. IFP, the Florida Association for Food Protection, great resources. Use your colleagues. You know, we are all food safety nerds, and we all love to talk about this stuff. You know, I kind of poked a bit at the regulators, but actually, I have to say, I have a lot of respect for my colleagues at USDA, at FDA, even at EPA, and there's a lot of good information available from them. Trade associations can be very useful. National Food Processors Association, Food Marketing Institute, the National Restaurant Association, all have very good food safety information. Universities love talking to academics. Again, they love this stuff. You know, Michelle, I see, is on the call. Any university you talk to, if you get a hold of their food microbiologist, trust me, it won't be a problem getting them started talking. It'll be a problem getting them stopped. They are eager to help you. And then, of course, your suppliers. Lean on your suppliers, whoever they may be. In diversity, we have a number of people who are very strong Listeria experts, literally all over the world. We're always happy to answer food safety questions, and it doesn't matter whether you're our customers or not. But your own suppliers will have them. You know, I wish I could say that that the diversity competitors didn't have good food safety experts, but in point of fact, they do. So use your suppliers to help, particularly if you're trying to figure out disinfectants and how they work, because again, they are different from sanitizers and are a good deal more complex. Okay, I think that was it. I guess questions now?
Yes, we have a couple questions here and just a few minutes left for them. So the first one, do you have some best practices to recommend for writing SSOPs to make them easily followable for sanitation employees?
SSOPs need to be specific generally to the equipment and to the specific process. One of the things I get a lot are questions about, give me an SSOP for using a sanitizer or using a disinfectant. I can't do that, because an SSOP needs to be quite specific. It's not just how to use a disinfectant or how to use a sanitizer, but it's how to clean and then sanitize a model XYZ slicer or a model 123 cooler, or how we're going to clean that every day, and what's the SSOP then for our deep clean. So be as specific as possible, as detailed as possible would be, I guess, my biggest single recommendation for that.
That's great. All right, the next question here is silver oxide snake oil?
Silver oxide is actually quite a strong biocide. I've looked at that years ago. In some environments, it's great. Silver oxide has horrible aquatic toxicity, so be cautious of that. If you get it into a waste stream, it's not good in a wastewater stream. Also, if it's in a public-facing environment, silver it can frankly turn surfaces gray. If it's residual that you're thinking of, sometimes there's some sort of funky claims that get made for some of the residual activity of some of these. It's a good biocide, but here's the thing. It has to pass the same efficacy standard that anything else does. So it's got to pass the exact same efficacy standards that a quat or PAA or bleach or anything else does. So in many ways, its efficacy is going to be the same as anything else.
Great. Next question, if Listeria is in control in a food production environment, is it safe to say other pathogens are also under control, or is there no correlation?
Probably yes. The caveat to this is there's been some recent studies. Haley Oliver's group at Purdue has done some interesting studies looking not just at Listeria. She's done a lot of work looking at Listeria, particularly in retail environments, but she's also looked at things like Salmonella and E. coli. In fact, we did a study just a couple of years ago, or just last year actually, looking at that. It is hard to find some of these other bugs taking up shop, essentially becoming resident in a food facility like a retail or food service facility. It's not impossible, but you generally find Listeria there far more often. And my belief, okay, I'm going to label this is opinion, I've got no data on this, that if you're doing what you need to do to control the Listeria, you will largely be controlling the other bugs too, because what that means is you're going to be controlling the biofilms that all these organisms are able to grow in.
Okay. We are at time right now. I don't know if you wanted to continue with the last few questions or this will be recorded.
I can stay as long as you folks want me to.
Okay, so it's great because this is going to be recorded so we can finish answering the questions now. So the next question is, one of the problems with Listeria is its ability to hide out of sight. Do you have recommendations on best practices to identify those hiding places to make sure thorough cleaning and sanitation is taking place?
Oddly enough, one of the best things I could recommend is look for the places that are hardest to get to. If something's easy to clean and sanitize, then it doesn't get cleaned and sanitized. So you kind of got to get down on hands and knees and look for damaged surfaces, corroded surfaces, hidden and occluded surfaces. You can do things like use ATP and other tests to look for high levels of soil. And where you find high levels of soil, you're likely to find high levels of microorganisms. It's not directly comparable, but it is kind of linked. I've seen things like, sprays to spray hydrogen peroxide around and look for fizzing bubbles, that kind of stuff. That may work if you have really high levels of microorganisms. Oddly enough, one of the most effective ways, if you're willing to do it, is to do microsampling and then start seeing if you can do essentially some molecular analyses to see if it's the same bug showing up repeatedly, and if you can begin to map it out on over your facility over time. But that's not a trivial process to do.
Mm-hmm. Perfect segue to the next question. I found that monitoring Listeria's presence is an important aspect of controlling it. Comment?
Yep, absolutely true. And again, particularly if you can use some of the more sophisticated methods to not just look for generic Listeria or Listeria monocytogenes, but to get it all the way down to a genotype. Because now you can begin to see if you have essentially a transient or a resident bug. If you have, a house bug that has taken up residence and keeps coming back, that means that there's some place you're not getting to where this thing is resident. And then you can begin tracking it a bit. You have to play a bit of detective sleuth here. So yes, I think that is an important part. And again, I would say that particularly as it gets cheaper and cheaper to do this sequencing work, I would recommend that you consider taking it to that next level if you can.
Great. And the last question I have is, with the increase in disinfecting, do you see any risks associated with that?
The biggest risk, I think, is misuse. This is such a different process for us. I do see some applications of disinfectants that are really, really questionable. The worst that I see, and I see this one quite regularly, are tunnels that are spraying disinfectants. They're recommending people walk through. That is a horrible idea. Many of these disinfectants are extremely dangerous to breathe in as a fine mist. So, spraying disinfectant so people can breathe it in or all over their skin or in their eyes, terribly dangerous. And by the way, wholly ineffective for controlling COVID. So I think that to some extent, it's some of the blatant misuse. For example, one of the things I know that the EPA has recommended or actually required is that if you're using electrostatic spray with disinfectants, you need to wear a respirator, either at least an N95 or in most cases, at least a half-face cartridge type respirator, and all that entails. Because you can't just buy a respirator and put it on. You have to be medically tested to ensure you have the lung capacity for it. You have to be fit tested, all that kind of stuff. So some of these things get kind of misused, and because we're not an industry that's used to dealing with it, it's easy for us to do. Again, lean heavily on your suppliers, and if you have questions, reach out for some help and advice on this stuff. Again, those of us in the industry love talking about this kind of stuff. So be careful of the snake oil, I guess, is the biggest risk with disinfectants. Disinfectants are safe and effective when used properly, but like anything, they can be misused.
Thank you so much. That's all the questions for now.
Okay. Well, you know, again, obviously always happy to chat with people if they have follow-up questions, you know. I think I know that Jason has my email, so does Rick Barney. If you reach out to the FAFP team, they can put anybody in touch with me if you have questions. Always happy to chat.
All right. Thank you so much, everyone, for joining. There's a list here that you can see of our future events that are coming up, and you can go straight to our website to register for them now. And if you have any questions, just reach out to us. Thank you.
Bye, everybody.